that they use for this bridge is called an I-bar suspension. We have a couple pictures here of the I-bar. Now, during the time it was made, this type of I-bar, the thickness and the weight of it was perfect for the vehicles that were going to go across it. Now, what the engineers failed to realize is that when the vehicles changed, they also needed to maintain the bridge, and they did not do that.
As Lisa said, this is a picture of a model from the time period when the bridge was first constructed and a car from the time of when it collapsed. And as you can obviously see, the weight is dramatically different, and unfortunately was, one of the main causes of why the bridge collapsed. Another main reason it collapsed was there was a very, very small crack in one of the I-bars. It was 3 millimeters thick, if I remember correctly. And it was not maintained, it was not inspected, nobody knew it was there. And during rush hour that day, just all the weight of the vehicles, all the weight of just the wind and everything going on was too much for this one I-bar, and it snapped. And it tilted the bridge over. 46 people lost their lives that day. And all it would have taken to prevent that is just one inspection to see that there was a crack, to shut down traffic for that day, a week, however long it would take to fix it. But because of the lack of diligence in that area, a lot of people lost their lives that day.
All right, so now we're going to compare it to another bridge that was built around its time, specifically the Golden Gate Bridge, which was built in 1937. This bridge has turned out to be a very successful bridge since then, and didn't go through the same catastrophe that this bridge went through. This is also a suspension bridge. However, this was not built as an I-bar suspension bridge. This was just built as a cable suspension bridge, which for this other picture, it shows kind of the thickness of that cable. You can see closely there. Basically this cable was expanded out through both of the towers of the Golden Gate Bridge and molded into the concrete of each side of the river. And then from then, they were able to build it very sturdy through the towers as well. And they also used a vertical suspension ropes that went throughout the whole bridge and spanned out throughout the whole bridge, connecting to the 2 main cables that were paired along the bridge itself. And then this right here shows a seismic retrofit construction project that they did. The company itself was called the Seismic Retrofit Construction Company, and the reason that they did this was because they noticed that because the bridge itself was very close to the San Andreas Fault, there was a lot of seismic activity and a lot of potential for the bridge to collapse and stuff. And as the years went on, they started noticing these kind of things. And this was one of the projects that they did in order to reinforce one of the parts. And they ended up adding some seismic retrofit and they're basically these black cylinders. I don't know if you can see them there, but they were used to be able to stabilize the bridge a little more and help it be able to maintain its ability and basically be able to hold itself through the seismic activities that could potentially happen in the future years. And then this next bridge shows itself, the Golden Gate Bridge itself. It includes, as you can see, the span of it throughout the river, and through all these improvements that they've done and maintenance that they've kept up throughout the years, it's helped it maintain its integrity, and even now, as of now, it's become one of the new modern wonders of the world, as classified by the Association of Civil Engineers. So this is our presentation on the Point Pleasant Bridge, aka the Silver Bridge. I hope you enjoyed, Mr. Mock.